Hi, my name is Jim Martin. I'm a solutions architect at Electrify, and today I'm going to talk to you about our building inspection solution using our computer vision machine learning models. So first, a little background on building inspections. Most big cities require periodic inspections of the facades of tall buildings. So for example, any building over 6 floors in New York City requires an inspection every 5 years. Well, there are approximately 9,500 buildings over 6 floors in New York City alone. The owner or operator of the building is the one that's responsible for paying for the inspection, and these inspections can be expensive and time-consuming. For a 30-story building, it takes about 4 weeks to do the inspection, and it costs about $20,000. Failure to comply with these inspections results in severe penalties, fines, increased building insurance costs, and legal liability from falling materials or fittings. Some of the typical faults and anomalies that building inspections focus on include things like structural and cosmetic cracks, water stains and accumulation of water or ice buildup in cold climates, loose brickwork, loose cladding panels. On buildings with a glass facade, they look for loose or misaligned window panels, corrosion of the metal or stone, air conditioners that are loose or don't fit properly, and missing child window guards. What are some of the challenges that come along with building inspections? Well, as we mentioned earlier, the building inspection process is very time-consuming. To inspect a 30-story building, it takes on average about 4 weeks. Photographers have to take hundreds and sometimes thousands of highly detailed photographs for each building, so that alone can take weeks. Then the photographs have to be analyzed, so someone has to scour over these thousands of photographs and do a thorough analysis on each one of them. These inspections can be very costly. And again, we go back to our 30-story building example. We mentioned that inspection costs about $20,000. And finally, as you can imagine, looking at thousands of photos can cause a person to get fatigued, and that can lead to errors in the analysis. So what's Electrify's solution for these challenges? Well, we've created a computer vision machine learning model that's been specifically trained to use video footage or still photographs and identify anomalies in the facade of a building. So the way this works is a customer takes either video or photographs of the outside of their building and then feeds those files into our model. Our model analyzes the files for anomalies, and then as output it creates a video file and a PDF report with the results from the model. We'll see examples of these later, but the video file highlights the anomalies that were found and also identifies their type and the confidence score that the model calculated for each one. The PDF report compiles all the results from the analysis into an easy-to-read document that can be used for follow-up inspections. So some of the benefits that we found when using our solution include a reduction of inspection time by around 80%. We were able to reduce the inspection time of a 30-story building from 2 weeks down to 2 to 3 business days. For building owners and operators who conduct their own inspections, that reduction in inspection time results in a significant reduction in building inspection costs. For building inspection companies, it means a significant cost savings as well, but also an increase in productivity, which means that their inspectors can perform more inspections in the same amount of time, and of course, more inspections means more revenue for the company. Because our solution removes the human constraints of fatigue and reduced attention span, it's likely to have an increased accuracy over the current process, and that means finding more risks, anomalies, and defects. After the analysis of the videos and still photos, there still has to be human follow-up to verify that the anomalies identified are actually valid. The report that we create specifies locations of the anomalies that were found, so any follow-up inspections can be fast and targeted. So let's take a quick look at one example of how this would work. So this is one example of a potential setup for a customer. We have a demo UI set up here, and in this particular instance we're using AWS for a model, but you don't have to use AWS at all. Our models are cloud agnostic, so we can work with any environment. So the setup we have here is in AWS we have an S3 bucket called Computer Vision Building Inspection. It's got an input folder, which we can see is empty, and an output folder, which we can also see is empty. So from our UI, we're going to upload our video file. It's going to drop the file in the S3 bucket, and that will trigger our model's our model to start analyzing the information. And it takes a little while, so we'll pause the video. But after a while, the model outputs the video and the report to the output folder. So first we'll select our file. And we'll send it to our S3 bucket. Our results say that it was successfully uploaded. We'll take a look at that. Check our input folder. And there we can see the file was successfully uploaded. So our file is being processed now, and we'll come back a little later and we'll see the results. So we're back, and our model has completed the analysis of our video. So let's check our output folder. It's uploaded the report, the PDF report, and also the video file. So let's go take a look at the video file and see what that looks like. Here's an example of the video output of our models. This building is in New York City and is known as the Superman building because it was used for Superman movies. This particular version of the computer vision model is trained to classify cracks and corrosion. So the cracks and corrosion we've identified are highlighted, and a confidence score is displayed for each one. What you'll notice is that when the drone zooms in closer, the confidence score for the cracks increases because the model is more confident that the anomaly is actually a crack. So we're training versions of the model to identify other types of anomalies that we talked about before. Structural cracks, cosmetic cracks, loose brickwork, poorly fitted or loose window air conditioners, etc. So let's take a look at an example of one of our reports. So here's an example of a report that was generated by our model. You can see that the report lists the video, the frame of the video that we're referencing on this page, the date the video was taken, the location of the building, a summary of the investigation of this particular area of the video, which includes a number of anomalies detected, the types of anomalies, in this case cracks and corrosion, and the type of material the building was made out of, in this case stone. Below the image we have a table with more details about each defect, the defect type, location, size, and priority. The information in this table is organized from highest to lowest priority. So one thing I want to point out about the location and size information indicated here is that for this particular video, these values represent a location and a size on the video itself, not on the building. This is due to the fact that the video that was used for this demo didn't include a full scan of each side of the building, so we don't have any reference points and there's no way to calibrate the video to that building. But in a production environment, we would have this information, and the locations and sizes would be a lot more descriptive. It'd be something along the lines of 18-inch structural crack suspected on the 23rd floor or something like that. Knowing this precise location information makes it a lot easier and faster for the inspection team to do their manual follow-up inspections on these defects later. So a quick recap of what we talked about today. We took a look at the many challenges around the current building inspection process. We saw that it's a very time-consuming process. We saw that it's very costly and is potentially error-prone due to the fatigue of people having to scour through thousands of photos. Then we took a look at Electrify's computer vision building inspection solution. We saw that it was easy for customers to implement. All you have to do is pass your files to the model and everything else is taken care of. We had an 80% reduction in building inspection time, which means significant savings for building owner-operators and building inspection companies. And for those companies, this also means increased productivity, which leads to increased revenue. And since our models don't have to worry about fatigue or reduced attention span, we can have more accurate results. Finally, our inspection report makes it easy for the inspection teams to do manual follow-up inspections on the defects that were found. Thanks very much for watching. If you'd like to get more detailed information on how you can get set up with your own building inspection solution, go to our website at electrify.net and schedule a demo that's customized for your needs.